Can y'all see the question?
I see it, sir.
Identify I'm going to abbreviate it on the next question. So what they want you to do is, here we start with numbers, but remember this GCF idea applies to algebra terms, fractions, and numbers. It doesn't matter. Basically any factor, because a factor can be anything. Could be an X, could be a W, could be a 7. If there's something in common, you can factor it out. So the first beginning of the homework, they just want you to identify what they have in common. The easiest thing to do is to factor everything and then just see what they have in common. That's it. So let me write these two numbers down of 30 and 45.
Is this in McGraw-Hill? I mean, Alex McGraw-Hill.
Yeah, this is the first question in your homework. Okay, so this is the idea. It's greatest common factor. So you can do a little skill tree if you want, or just write them down if you're good at your times tables. But just keep going until they're prime. So we can do 5 times 6, right? 5 is prime, so keep going. 6 is 2 times 3. Now do the 45. Much of the side somewhere. What's some good factors of 45? Doesn't matter, just any of them.
5 times 9.
Yeah, let's try that. 5 and 9. 5 again is prime, and then factors of 9. So we can say that what they have in common is what? What prime numbers?
5 and 3.
1, 5, 1, 3, right? So 30 is equal to 2 times 3 times 5. 45 is equal to 3 times 3 times 5. So they have these two in common, right? So that's the answer. 15. 15 the GCF of 30 and 45 is 3 times 5, which is 15. That's all we have to do. Are there any questions on this idea?
No. I think I understand. I'll have to write it down first. Can I copy it?
Yeah,
I'm missing the last part.
the bottom part or top part?
The bottom part.
Yeah, no worries.
What if one of the numbers are negative?
You would just you mean if one of the numbers in question, like from the problem right here,
Yes.
that wouldn't matter. You would just disregard it.
So just
'Cause
treat it
we're
as
only
a
looking
positive number then?
Yeah, pretty much. Just know that technically it's a negative number, but the factors is what we're looking for. Because you can always factor a negative out and not focus on it.
Okay.
So we're looking for the greatest common factor. So um, technically they both have a 1 in common because they're both positive. They're both negative. You could say -1, but we're not gonna do that. So prime numbers for numbers. That's what we're looking for.
So like when you split it apart, when they both have like a 3 and there's a 2, so there's a 3 that goes on the outside, then there's the 2 and 3 that go on the inside.
Yeah,
Or
so I factored 2 at a time. So I took 30 and I broke it down to 5 times 6. And then I took 6 and broke it down to 2 times 3. So that means that 2 times 3 times 5 is 30. Right? 2 times 3 is 6 times 5 is 30. Do the same over here. 45 is 5 times 9, and then 9 becomes 3 times 3.
so putting them together, the GCF of 30 and 45 is 3 times 5 is 15.
Right, because those are the factors they have in common. And factor means basically what multiplies to give you this answer. What
Ah.
you think? Okay. Alrighty. So now this one's a little harder. Number 2 from the homework. We got 3 of them. So do all 3. So what are some factors of 42?
Seven times 5.
It's close. 7 times 6, right? 7 times 5 would be 35. Yeah, 6. 6 right there. All right. 88. What about 88?
Do 8 times 11.
Yeah, this is not too bad, right? Okay, so those are all the prime numbers. $60. Don't really matter. Just pick the easiest ones you can think of. Because eventually we're going to get down to primes. So it's all good. See what I mean? So write them in their factored form and then just, or you can just circle the ones you have in common and you're good. 42 is 2 times 3 times 7, right? I'm putting them in ascending order just because it doesn't matter. 2, 3, 7. 88 is going to be 2 times 2 times 2 times 11, right? 60, 2 times 2 times 3 times 5. So what is the GCF?
2 and 3.
Looks like they all have to have in common at the same time.
So then it'd just be 2.
Yeah, it looks like it's just the 2.
Okay, so for another number to be also included in the answer, it has to be in all of them at once, at least
Yeah.
once.
Yeah, and another way to think about it is so they all have to contain the exact same factor, or that factor that we're talking about needs to be able to divide into all three of them evenly. Only 2 can do it. Just 3 will not go into this one, right? But yeah, that's just 2. Are there any questions on this on the GCF idea?
On one of my questions, I got what's the factor of 30 and 52? So mine's kind of different, sir.
The greatest common factor?
Yeah, the greatest common factor 30 and 52.
30 and 50, it's the same thing, just factor it down to prime numbers. Break it down just till it's just primes.
Numbers that I can factor until I can't.
All right. Let's move on to something else, unless y'all have a question about um, identifying the GCF.
Um, what if we don't immediately have like how do we figure out which one we can use to break it down, like 52 for example and 30?
You pick any number that divides into 52. So it's even, so I would start with 2, right?
Uh-huh.
So what you could do is this. Like, let's say you're really bad at multiplying or dividing. You don't want to think about it. So you could do this. You could say, you know what? I don't know what the hell goes into it, but you can take the 52 and divide it by 2, and then use 2 and 26. Or I could maybe try something bigger. Let's see, I don't know, maybe 3. 3 doesn't work because I got a decimal. Let's try 4. 4 is pretty good. So I would do break it down into 4 and 13 because it went in and it went in and gave me a prime number. So I would use
But,
4.
but would it matter which one we use, like 2 or 4?
It does not matter. You just keep going until you got prime numbers until you're done. What path you take doesn't matter. What matters is what are the prime numbers you end up with. That's it.
So it could have multiple answers.
No, it'll be the same answer no matter what path you take.
Hmm.
On the your path might look different, but the answer will be the same. Because you like, for example, right? Here we use 5 and 6. I could have used 3 and 10, right? But it would have been the same at the very end. It still would have been 2, 3, 5. Okay. So the first step is trying to identify what is the GCF. The next step is factoring it out of your questions. Let me see when that starts. Let's do this one real quick because it's variables. And then we'll move on. So identify the GCF of x3, x8, and x9. Okay, so these are a lot easier, but first you got to see it. So let's go through this, right? You factor them just like before, but instead of a tree just to save space, and it's also obvious, you agree that x cubed is the same as x, right?
Yes.
And these are prime because I can't go any further. So by definition, cannot factor any further. Do the same for all 3. And then tell me what they have in common. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do they have in common? Should be clear.
That they're all X or they all have at least 3.
Yeah, they have exactly 3 in common, right? 3 factors. So the GCF is equal to this, which is, yeah. Is that clear?
Yeah.
Yeah. So
It's,
we're just
it's
looking for what they have at most in common.
Right.
And in this case, it'd be x cubed.
Mm-hmm. The exact same thinking, it's just not numbers. You see what I mean?
Yeah.
Yeah, it's just the amount that they have that's in common.
Right. So think of it as in terms, don't think of it as numbers or letters. Just think, okay, what do they have in common? That's it. What is it? I just write it down. Okay. So they had x cubed in common. And once you do this, once you do many of these, you just assume that the smallest one is what's going to be what they have in common. Because there's no way, like these have up to 8 and 9, right? But this only has 3. So it can never be more than 3 for this example. Okay. Are there any questions on number 3?
No.
So anything that can be factored could have some GCF stuff. Like check this one out. What do these two have in common?
3x.
Plus y.
Yeah, so treat this is a factor here, 3. Anything that you're multiplying together are factors. So 3 times this, 3x plus y are 2 different factors. 4 times 3x plus y are 2 factors. So they both have this factor in common. So your answer would be that they both have one of these. It looks weird, but let's not overthink it. They have this thing in common. That's the answer. That's it. That's the GCF. Does that make sense?
That's it.
That's the GCF right there.
So it's just looking for anything they have remotely in common.
Yeah, so you're looking for things that you can multiply together. Once they're all multiplied out, factored, right? Sorry, I should say once everything's factored out, what pieces do you have in common? Like don't overthink it. Don't be confused by a bunch of pluses and minuses. Like there's this thing in here, and the other one has a 2. They're products, so I'd take the 2 products they have in common. That's it. Does that make sense to everybody?
Yeah.
Just this. You would type this answer.
3x plus y.
Mm-hmm. Parentheses are not necessary, but I think it makes more sense. All right, so this is when they're no longer just asking for the GCF. They want you to actually pull it out. Okay, so by looking at 2p and 10, look at these two separately. What do they have in common?
Multiples of 5.
Yeah. If you factor them out, you get 2 and then the parentheses p plus 5.
Well, that's the answer, but I'm asking what do they have in common? What's the GCF before we factor it?
5 or no, 2.
2, right? So the GCF is a 2. The first step when you do is identify what is GCF. Next step, pull it out. Factor out the GCF. So that's why they care about GCF. That's your very first factoring technique.
So on equations like this, where it says something like 2p, to get the p by itself, where we have to like do that graph and then show p by itself downwards, and then the 2 next to it.
You could, yeah, you could do this, right? You could say, you know what? 2 and p, well, that's just 2 times p, right? Is that what you're saying?
Yeah.
And 10 is really 2 and 5. So I know that they has these 2 in common. So I'm going to factor out a 2 from both of them. And whenever you factor, that's basically division. You're dividing it out. You're pulling it out from. So I never show this step after doing it so many times, but for the very first time, this is technically what's happening in the background. I pull the 2 out, so everything gets reduced by a factor of 2. That's what factoring means. I'm factoring out some term and reducing everything by that factor. So that would give us the answer you guys were saying, right?
It's a lot easier to simplify it with taking out the 2 rather than writing it, but that's just me.
Well, this is the explanation. This is what's going on.
Yeah.
But if you go from here to here, I'm not going to be mad about it because this is a simple question. But if you've never done this before, this is why it works, and this is relating it back to what we just learned and why we did those questions. Any questions on number? Actually, that's not 4. What the hell is it? I don't know why I wrote that. That's 5. Last one was no. Um, oh yeah, this is 5. Did 4 on the screen. That's right.
Well, I'm confused on one thing. Why is the 2 still there if we've separated the 2 on the ends?
So this is not an equation. So I'm doing something, but not really doing it. So for what I mean by that, let me put the screen back on. Where'd it go? Oh, here it is. Right. If I were to multiply the 2 back in, what would I get?
Oh, okay, so it's just simplifying it, basically.
I'm basically putting it into a different form. I'm not solving. I'm not simplifying. I am factoring a 2 out from the entire question. So I removed 2 from both. So inside here, they no longer have the 2, but it's still technically there.
Oh, okay, I see what's going on now.
That's what factoring means. We're just putting it in a different form. We're undoing the multiplication. That's actually what it is.
Okay.
The answer is this one here, by the way. 2 is the GCF. When they said factor out the GCF, that means factor out the 2 in this case. And any other questions on?
Not that I know of. I feel like it's pretty simple over here.
All right, let's do something a little harder, but still the same. Let's do the next page, I guess. Next one was 6.
I think I figured it out, sir.
Awesome. Well, let's see if we get it together. Oh shit. So 6, right? We said? Yeah. All right. Things being blurred for some reason. Okay. Let's see how it goes. Now, if you don't see it, or if you're bad at multiplying in your head, then break it up on the side somewhere. The first thing we should think about is the p's, right? If this has 3 p's, this has 2 p's. So at most, how much do they have in common?
P squared.
Yeah, so they can both, you can factor out p squared from both, right? Now, the numbers, if you can't see them, let's break it down real quick. 42, right? 18. Okay. So what numbers do they have in common?
So would the answer read as 2 times 3 times P squared?
So yeah, the GCF is gonna be 2 times 3 times p squared. So that's what we're gonna factor out. Or in other words, 6p squared, right? So pull out 6p squared from the entire thing. So that's as if you're dividing everything by 6p squared. What does this become? What's 642 divided by 6?
8.
42, 7. And notice these are gonna reduce, right? P cubed and p squared. To be left with a single p. These are completely gone. 18 divided by 6. This will be your answer. So you can think of this in many different ways, right? You can think of it as, well, they're both going to lose p squared, or at least, in other words, p times p. So this will be gone. Only one will be left here. That's how this comes about. I'm dividing both by 6. That's how I get 7 and 3. Okay, so 42 divided by 6, p's reduce. 18 divided by 6, p's reduce. Are there any questions on finding the GCF and then factoring it out?
No, sir. I think I understand it now.
So this is the answer they want.
I think I figured this one out.
I have a question. After the, like on the second part of the equation, the 18p, why did you put like on the piece, like why did you put that dotted, sorry, not the dotted, the line?
Oh, I'm canceling them out because they're both the same. P squared over p squared, that's just going to be 1, right?
Yeah.
Like 4 divided by 4 cancels out, leaves you a 1.
Okay.
Technically, these are all canceling out and reducing, but this one was the obvious one. I'll erase it for now. Doesn't matter. Okay. So that was 6. Let's see, 7, I'll let 7 to you. 8, same thing. And it looks hard. Let me do that one for you. Factor out the GCF. (28) a to the fourth b cubed plus 8 a cubed b4 minus 20a squared b5. So there's three terms. And we got numbers and two types of variables. So we got to find the GCF first. So if you're bad with the numbers, just go ahead and factor them down. 28 is what? 4 and 7, right?
Oh, that one. That one looks like a lot. Holy moly.
8 is 2 and 4. 4 is 2 and 2. 20, 5 and 4, 2 and 2.
I feel like the greatest common factor could be either 4 or 2. Because they all have 4 in it and they're all splitting the 2.
Yeah, I mean, I think you're right. They all have a 4, or which is the same thing as saying they all have 2 times 2.
I feel like since I started, I did that on one of mine. I managed to figure out if even if you manage to split it apart, if there's a common number between all of them, then that could be the number.
Yeah, that's fine too. Mm-hmm.
And you don't have to like multiply it. That's just like the simpler way of doing it for some of them. Not all of them can do that, but some of them you can.
Yeah, when you get more experience, you'll see faster ways of doing it. But when you got it down to primes, it's always going to work. So that's why I'm doing it this way first. So just look at the primes so we don't have to think too hard. But once you do a lot of these, you'll see, oh, technically I could just pull the 4 from all of them, which is the
Yeah.
same as this. So the GCF contains a 4 for sure. 2 times 2.
Yeah.
Now, at most, how many A's do they all have in common?
They all have 2 A's.
So A squared would be part of the GCF. Does everyone see why it's 2?
Yes, because the lowest is an A square and everything else is higher.
That makes
And
sense?
same thing for B. Lowest is B, so therefore there would be B cube.
Yeah. So always choose the lowest one, that's right. So B3, B4, B5. So at most, they can only share 3 because that's the minimum.
Yeah.
2, so they can only share 2. So here's the GCF. Any questions on finding the GCF before we pull it out?
No, sir.
Does it matter what order do you put when you are find the GCF? Like, does it matter?
Like this one right here, or these, the way we break these down?
The way we break those down, because you see, this is my answer for the 20. I didn't copy from the page that you're doing. I just put 20 and then I put 2 times 10 makes 20, and then I put 5 times 2 makes 10. So I mean the numbers are still the same somehow, but doesn't matter if I do it like that.
It does not matter. The answer is the same. You're correct.
So when let's see when there's the question in Alex and we're gonna type down the numbers, would it be like give me an error if I put it like 522, or 2, 5, 2, or would it be the same? It don't matter how, in what order I put it.
If you're talking about the final part,
Yes.
unless it tells you, it shouldn't matter because it's all equal. But
Oh,
usually we prefer ascending order, but
what is ascending order?
technically it does not matter mathematically. No. 252, 225, 522 are all the same.
Okay. Thank you.
I think I figured it out. I figured this one out, sir.
Nice. It's good.
I'm starting to get my memories back, sir. I'm starting to remember.
Yeah, you have all done this before. This is true. Yeah, this is a review section, part of the correct. So trying to remind you how to factor because you're going to need it. So this is the first factoring technique out of a bunch of them. Okay. So here we go. So 28 divided by 4, what does this become?
That one becomes a 7a a square because you don't need the b because it's already they're both equal.
Yeah. Oh, let
B3,
me show an extra step just in case some of you don't understand. When you divide the same variable, you remember you subtract them, right?
Yeah.
And these are the same. So this is technically 3 minus 3.
So it'd just be like no b there.
B0, which is a 1.
B0, yeah. It would just be equal to 1.
8 divided by 4. A cubed minus 2. B4 minus 3. 20
Yeah.
divided by 4. A squared, so that's going to be gone. B5, B3, right there. But if you want to skip that in between step, that's okay. I'm just showing you why this is the answer. Going extra steps just in case. B0 is equal to 1, so that'll be gone. This is the final answer here. Any questions on example 10?
No, sir.
Right. All right, so let's move on to something else. So that was factoring a GCF out of terms. That's it. So now we're going to use that idea to be able to factor by grouping.
Can I have one more second because I'm writing it down just
Oh,
to
yeah,
go
sure.
back in the picture. Yes.
Yeah, no worries. Let me put it back.
Thank you. Okay, I got it. Thank you.
Cool. Let me get caught up on my messages. Okay.
I
So
was,
moving into grouping. Sorry, what's up?
I was gonna ask if you're recording this Zoom today.
Yeah, I am. I'll make sure to send it as soon as it's done processing. I think it takes like a couple hours.
Okay.
Okay, so
That
this is
that,
the
that was kind of
first step
similar.
into grouping. So let's do this one and then we'll go to grouping. Okay.
That's
Number,
similar to the other one.
yeah, it's very similar to the one we talked about. But just so we have a reference, we'll do this and then move on. And I guess you could, well, let's see. All right, 4z times 8z minus 9 times 8z plus 5. Okay, so first thing, so these are two products, two factors. Technically three. We got 4 times z times 8z plus 5. So this is multiple factors, right? If you look at the 4, is there anything in common with and actually these two? I have enough space. This question has two terms. 4z times 8z plus 5 is the first term. Negative 9 times 8z plus 5, second term. So do you all remember what a term means? I'm using terminology, but y'all need to know what it means.
There, there's something I don't remember exactly, but they're supposed to be like separate on something.
Yeah, anything separated by a plus or a minus is a term.
Yeah.
And anything separated by multiplication are factors. So we have 4 times z times 8z plus 5. These are three terms. And I'm sorry, three factors. And then these two things are two terms. This.
Yeah.
Okay. So factor the GCF out of these two terms. What do these two terms have in common?
8z plus 5.
So if you pull that out in front, what would be left inside?
It would be
And if you
4
don't see it, let's show the work. What was it?
4z minus 9.
Yeah. So this step is not necessary. I'm doing this just to make sure that you see it. Okay. Or if you're just don't like multiplying. These are gone. These are gone.
Yeah.
They're gone because we factored them out front. So we're left with this.
Yeah, that looks about right. I think I remember this.
So this needs to make sense before you do grouping. Yeah. Oh, I guess one quick thing. If you factor a negative, just put the negative in front and swap out your signs. That's it. Yeah, see what I'm saying?
Where?
If you put out the minus in front, so everything would turn positive. So you get a,
Oh.
or it'll turn opposite, I should say. So originally we had -5, -7, +3. Now we have 5, +5, +7, -3. So you just swap them. Because if you have a negative in front, that means you're technically going to distribute on all three. So if I pull it out, it would just switch them. Does that make sense?
Yes.
So there's an invisible -1 there, like that.
Yeah, so if you pull it out, you undo the negative, but it's still there waiting for you. So sometimes you do that in order to make the question easier. But it's technically still there. You can't just get rid of it for no reason. So if you need the signs to be a certain way, that'll happen. Let me try to find the
So
grouping
that's all you
question.
did. You just factor out the -1 in there.
Right. So when you factor out a negative, put parentheses and a minus whenever that happens, whether there's a 7 or a -1 or -7, whatever. Everything inside the parentheses will swap signs.
So was the answer just -1, or was it everything in it?
No, the answer would be everything. You pull out the negative and swap all your signs.
So it would be -1, parentheses, and then everything else.
Yeah, just but the opposite signs.
Yeah.
All right. Let's move on to grouping now. That's enough of that. This is number 35, 36. So this is 14. Factor by grouping. Okay. So this is how you do grouping. You basically group two at a time and pull out a GCF, and then hope that the GCF you pulled out matches. But these questions, for the most part, they should work. They should match. Yeah. So look at the first two. What do they have in common? What is the GCF?
Y.
Y and what else? If 6 and 15, they both have a 3, right? Do you agree that they both have 3y in common?
Yes.
Oh, we're still factoring those down. Okay, yeah.
So I'm not showing all the steps this time, but if you don't see it or have an issue, let me know.
So
I,
it'd be
I don't have an
3y.
issue, but I don't have an issue, but I actually came across a question on my assignment that I got wrong twice.
Oh, we can talk about it after we finish.
All right, I'll talk about that and everything else.
Okay. And these both have what in common?
5.
5 and
Two.
B.
B. Yeah, right. They both have a B. They both have 5. Okay. So this is what you do. Your first step is, let me write a note here. First step, group 2 together. 2 terms, I should say. Group 2 terms together. And factor and find the GCF. Second step is factor it out. Okay, so if I'm going to factor 3y from the first two, do you agree that I'll have 2x plus 5a?
Yes.
Factor 5b from the first or from the second two, do you agree that I'll have 2x plus 5a?
Yes.
Do you see that they have the same thing in common now? So that's the goal. You're factoring these two at a time and then hoping that you're going to have something they both share. So factor this in common. And then these would be the leftovers. See what I mean?
I'm trying to write it down, sir.
I was writing it down. I missed the part where you find the last. How do you get to the last answer, the final answer?
Do you have to like put it on the end, like when you use the outside, you like 3y, 5b, those will go to the end, not the beginning?
Well, mathematically it doesn't matter, but to be consistent with the last few examples, we're pulling out this. Whenever we factor something out, we always put it in the front, right?
Mm-hmm.
Any questions?
I'm still a bit confused on how the 3y and 5b end up at the back.
Okay, well, let's go back to the last question. I think it'll make sense to think about it like this, right? Remember we pulled this out of both, right?
Mm,
Yeah.
So when we did that, right? When we did that, I forgot my parentheses. My bad. Minus 2 points for me. This leftover went right here, right? So this is the same thing over here. I just didn't show that all that extra stuff. So I'm factoring this. I'm pulling this off of both of them. And I'm left with these things that were not factored.
Yeah. Is this factor out the GCF or is it factor like
So what's
organized?
left over becomes its own group.
Let me show more steps. Excuse me. I don't know how to breathe right. Here we go. So I'm put brackets just so it's a little prettier. Pretend the brackets are the same as parentheses, so don't let that bug you. So factoring out, oops. All right, so when you factor, we said we divide it out, right? See what I mean?
Okay,
Yeah.
I see it now. Okay. We just didn't write out that part.
No, I didn't because I've been showing a lot of steps. So I was beginning to show less steps, but it was too soon. It's my fault. So, but the way I think about it in my head, but I have a lot of experience, right? So when I factor something out, I'm basically peeling them off.
Yeah,
And
and then so then
and
we're just left with that being the other group.
mhm. But
So
this is
basically that
the
just turns
one.
into its own group because we took out that factor.
Yeah.
Hmm.
Sir,
Okay.
could we do one where we that it looks like that where it has like the no it looks like something like 5a and then parentheses 7y minus 4f and like the factor out the GCF. Do you know if we can do that one?
GCF. I mean, we pulled the GCF out of the first two and the second two. We grouped them together, right?
Mm-hmm.
So I pulled out 5B from these two, got this. Pulled out 3Y from these two, got this. So we were doing GCF. We've been doing GCF the entire time. That's technically how you do factor by grouping. But I'm not sure if I understand your question or your request.
Um, I was requesting if we can factor out the GCF.
Like out of these?
Um, out of out of the second step where you had 3y, 2x plus 5a, and then plus 5b, 2x plus 5a. If
Yeah,
we could,
that's exactly what we did.
yeah, because I did it and I did it on one of mine that was similar to that, but I got it wrong twice. I don't know how.
Hmm. All right, well, we'll have to work on it after we're done with this lecture. We'll go through it together. Don't worry.
All right.
I'll save some time. We'll have some time. But as far as this one, you guys understand it?
Yes. Yes, sir.
Okay. Let's do this one looks a little easier. Let's see. Remember, when you're doing grouping, it's not always guaranteed. Sometimes when you're grouping, you see how I picked the first two and the last two, and it just happened to work out, right?
Yeah.
Because we have it. So first thing you always do is to start from the beginning. Check if all four have a GCF. If they don't, move on and say, okay, well, if I have four terms, that means I should attempt grouping. It does not mean that grouping will work. See, as you can see right here, it says cannot be factored. Sometimes it can. Sometimes picking the first two and last two doesn't work, but switching two around and then trying it again does work. So you need to try different things. Okay. Try at least two attempts in different orders before I would choose cannot be factored. Most of the time it'll work just as is, but once in a while you're like, you know what? If like for example, let's say I did it the way I just did right now. Say I group these two and these two, and then it doesn't work. I'm like, well, I would end up what I would do is switch this one with this one or something. Just move them around and then try again. Just rewrite it. So you never know. So if that still doesn't work, I'm like, okay, now I'm starting to believe it's not possible. Then I would choose this. So keep that in mind. Vector by grouping. That's 6. Okay, so look at the first two. What do they have in common? What is the GCF is what I'm really asking.
B.
Yeah, all they have is a B in common. What about these two?
3.
3. So go ahead and factor them out. So once you find them, pull it out from the first two, pull out a B. I'm left with A plus 2. Next one, I'm pulling out positive 3, so I'm putting plus 3 here. So that would be
A
A
plus
plus
3.
2, right?
Uh,
So now
why?
this is what we want. You see what we forced it to be this?
Yeah.
So what do we do next?
You put
There's. I don't think
you
there's anything
put
we
it
can do.
together where you have the B plus 3 on the end, and then A plus 2 together.
What's the GCF of both of these terms?
A plus 2.
So since they both have it in common, then we factor it out.
A plus 2, B plus 3.
Yeah, it'll end up being B plus 3. But I'm going to show my work one more time. Divide this out. Any questions on grouping? So this is what factoring by grouping is. You group two together, pull the GCF out, and then hope that a GCF of the entire thing appears. Once it appears, factor that out of everything, you get to here. And then that's it. Sometimes you'll have this may still have a GCF, but not all the time. Not often. Good. You guys cool then?
Yeah.
Good. Just make sure. Well, let me find something that has negative signs. That way you can see that it can get weird sometimes. 'Cause I know you're some of you are gonna get really lost with the negatives.
Yeah, there because the one that I have has a negative in it. 7y minus 4f. Maybe that one could be a weird one. If it has a negative in the parentheses, that's something I came across, so that's probably why I got it wrong.
Yeah, you just gotta be very careful. But this is the last one on the homework. I think this will cover most of our bases. Well, let's see.
Number 18.
Yeah. Okay. Actually, I should say factor the polynomial with grouping. If possible. There's no guarantee it's going to work. Not everything can be factored. Okay. So remember, we said the first thing. What was the first thing we should do?
Find the GCF.
Find the GCF. What's the GCF of all four of these?
X squared.
X squared for sure. What else? What they all have a number in common?
2.
Yeah. So we should start by pulling out 2x squared first out of everything. So this will reduce by 2x squared. I'm going to skip some steps. If it bothers any of y'all, let me know and I'll show more.
On the first 2x, is that a 5? Or is that a 3 up there?
This is a 3. This is a 5.
Oh, okay.
Yeah, I know my handwriting's trash. Don't worry about it. Okay. So, nothing in common now. So we're going to do grouping on these. This guy just going to come along for the ride. Doesn't matter anymore. It will be on the final answer tacked on, but it holds no bearing on anything we do in here. Okay. Doesn't matter. All right. So what is the GCF of these two here? Do that first.
X squared.
These two?
3.
Okay, so factor out x squared from the first two. That'll leave me with x minus 5. Factor out a plus 3. That leaves me with x minus 5. Y'all agree?
Yeah.
Okay, so now we got what I wanted, right? They both have a GCF, a common factor. So pulled out x minus 5 from both. That will leave me with x squared plus 3. Any questions on these steps? Do you need some more steps, or is it clear? Is it weird? Is it confusing?
I'm currently still trying to work on it, sir.
I just don't understand how it was x squared.
This part?
No, more of,
Oh, why these two have x squared in common?
yeah. Okay, never mind.
Oh, you see it?
Yeah, I see it.
Okay. Okay. So that's it for this section. This is assignment number 9.
Yeah, I would like help if that's okay. If that's the time.
Yeah, hold on. Let me see where we're at.
Wait.
Oh, no, we're not. Oh, when we finish the lectures, we'll do some homework. Well, let me see if we need to do one more still.
Oh. Could I get help on a question, sir?
Yeah, hold on. But we still have one more section. Let me see how long it is. Yeah, let's take a 10-minute break, and during the break we can do your question.
10-minute break.
Yeah, we'll do your question during the break if you like, unless you want to wait till after class. Okay, so assignment number 10, I think section 2.4, 2.3. First, it starts off with multiplication. The goal of this section is to factor trinomials and binomial. Okay, so first let's think about multiplication because we want to undo the product. So we want to get to here eventually. So what I recommend when you're doing any kind of binomial multiplication or trinomial times binomial, whatever, I prefer you think of it this way because it's a little easier. So just do 3p times all this stuff and then -5 times that same thing. See what I mean? Now it's just a distribution question, which is just something you've done quite a bit. So 3p times 3, 3p times 2p, -5 times 3, -5 times 2p. Does that make sense? It's multiplication. Any questions?
Yeah, I'm just writing it down. All right.
I'm gonna send you guys a factoring sheet real quick.
Are
So this
Remind
Yeah, well, I'll throw in the chat, but also remind, yeah. So there's a lot of factoring techniques, but I'm going to give you a flow chart that tells you which ones to use at what time, but also the formulas themselves.
Yeah.
Here it is. It's in the chat box. So just download it and open it up. I'll go ahead and share it too, just to go through it real quick. Can y'all see the PDF?
Yes, I
Okay.
can see it.
So at the very top is the beginning. The first thing you do is look, is there GCF for our problem? And then count the terms. If you have 3, then you have to use, could be any of these techniques here. If you have 2 terms, then you'd go down this way. Could be these. If you have 4, it's usually grouping. If not, it's not possible. But always begin with GCF. Okay. So this is your
Yeah.
guide. And in here we have all these formulas everywhere. Who cares? All right, so let's do this first question here. Factor the trinomial. Completely. By using any method. P squared minus 10p plus 16. So, first thing, do we have a GCF? When you look for all 3 terms?
It, there's a negative.
But do they have a GCF, all 3?
Does it appear so? They're all different.
Yeah, there's nothing that all 3 of them have in common. So no GCF. So the next thing is count the terms. How many terms we got?
We have 3 terms.
3. So check if it's a perfect square or AC method or trial and error. On your flow chart. Now, whenever I see that the P or the first term, the square term, doesn't have any number in front, as an invisible 1, then I'm going to try trial and error. This is the one that you've done many times, I think in middle school and high school, over and over again. So let's do it, just to remind you. Right, remember you take the P squared and see what are the factors of 16 that add up to negative 10.
8 and 2.
Yeah, so they gotta be negative though, right? Negative 8 and negative 2. So -8 times -2 is +16. So this, and when you add them together, -8 minus 2 gives you a -10. So that's how you check if it's correct. So they have to add up to the middle term. They have to multiply to the last term.
Yeah.
So what I do usually is just make a little table over here and say, you know what times what is 16, 2 times 8, or -2, -8. And then sum them on the side. So 2 plus 8 is 10, -2 plus -8 is -10. And you can keep going all the way down. 1 and 16 is 17. See what I mean? So this is if you don't see it right away, this is what you would do. Um, so you would choose this one because it adds up to the middle term, and when you multiply, you get 16. So that's where these came from. Is there any questions on that idea? That's trial and error, if you remember.
I remember that.
So use trial and error when the coefficient of the quadratic term is 1. Any questions on number 2?
No, it's pretty simple, it seems.
Okay. Let me know if there's any issues.
All right.
Number 3, let's see what it is. You're same type of deal. So let's move on to something else. Number 4. Let's try this one. Do one more of these and we'll move on to something else. Another trial and error type. I'm gonna use capital Q's because my Q's look like 9s. Okay, so I'm gonna do it the long way just because not everyone remembers all this from middle school or high school. Okay, so -12, do the factors. -3 times 4, 3 times -4, 2 times -6, -2 times 6, 1 times -12, -1 times 12. Okay. Sum them up over here. Negative 3 plus 4 is 1. Negative 3 minus that is negative 1. 2 minus 6 is negative 4. Negative 2 plus 6 is 4. 1 minus 12 is a negative 11. 11. Okay. So which one is the one we want?
The 4.
Negative or positive?
Negative.
So we're going to use these two as our answer. So plus 2 because it's positive, minus 6. Order doesn't matter as long as we're both there. So after a while, you can probably do this in your head and just jump to here, and that's totally fine. But this is the explanation, but also this will be helpful for the next technique. So you might as well do it anyway. Any questions on this guy?
No, but I do have a question on the other one where we had like the parentheses 3p minus 5, 3 plus 2p, that one.
The
The
last
one where
question?
the previous question before this one where you multiply 3p and parentheses 3 plus 2p, and then the same thing with 5, and you had the answer. I don't know if it's a missing step, but shouldn't you combine like terms, sir?
Over here?
No,
Oh,
above
the first one.
the first one. Shouldn't
Oh,
you
yeah,
combine?
you're right. I didn't combine like terms.
Yeah, because I tried it without combining and I got it wrong.
No, you should always combine it. I just didn't finish.
Yeah, I was just asking.
No, you're right. They should always be reduced and simplified.
Yeah, simplified.
There we go. Yeah, I think I just moved on and stopped caring. My bad.
Yeah, that's fine. And you should organize it too, like have the highest, like 3y square at the front, because the numbers.
Yeah, it should usually be the highest power first.
Yeah.
Okay, so this one is different technique. This was trial and error. The next one will be AC method. You could brute force it and do trial and error, but I don't recommend it because you're basically just guessing until you get it, which is annoying. I don't like doing that. But if you want to, it's up to you. I recommend AC method whenever we have a number in front of the quadratic part. See how over here we had a 1? Now we have a
Yeah.
So AC method comes from this idea, general form. So you multiply the A and C together, which in this case is 5 and negative 2. So you take the negative 10 instead of the final number. You use this. So factors of negative 10 that add up to negative 3. So here we go. Negative 2 and 5. 2 and negative 5. Negative 1 and 10. 1 and negative 10. Sum them up. That gives us a 3, minus 3, 9, and minus 9. So which one should we use to start? Do you see how the
The
beginning?
-3.
Yeah, there we go. See how the beginning is very similar to the last method, right? So this is where it changes. So you take the middle term and you break it up. You see where these numbers came from?
Yeah, they came from factoring.
They're from these two, right?
Yeah, so we just took those two numbers and then plugged them in.
So yeah, so we're breaking the middle term into these two. So what this is doing for us is forcing it into a grouping question that's gonna work. We're basically rigging the question on purpose. So now it's a grouping problem.
So then it would turn into 2z squared minus 2.
So what do these two have in common?
The 5 and the z.
These two. See what I mean? Pull out the 5z out of the first two, we'll get z minus 1. Pull out the 2 from the second group, get z minus 1. Now factor z minus 1, and we're done. So we're basically forcing this question into a grouping problem and then doing grouping. That's what AC method is. We use the A and the C to find the number we need to break down and force it into a grouping problem that's going to work. Is there any questions on these steps here?
I'm trying to copy it down right now. So when you factored it out, you have z minus 1 and for both, right? You just factor both of them out.
Mm-hmm.
Then it would just be the same thing. Z minus 1, 5. Does that say z right?
5z plus 2, yeah.
5z plus 2.
Yeah, I put lines through my z's so that to distinguish them from 2's.
Yeah.
Any questions on AC method?
I don't have any question, but when I'm doing the assignment, sometimes if I get it wrong, I just put give me a sample of how to do it, and it give me a little explanation. I write it down, and then I do another one or try another one. So I think I'm good with this.
Yeah, that's a good way to practice.
Yeah, and sometimes you explain it some way that I might have a question, but when I actually do the assignment, I check on the example, I write it down, and sometimes like it abbreviated to the point that I am like I understand it better sometimes. If not with the video, but yeah, I am good.
Yeah. Yeah, the more you see it, the better.
Yes, and multiple ways of seeing it also like
Mm-hmm.
clears make it more clear, I would say.
One of my professors used to tell me, you learn mathematics in a spiral. So each time you go around, it gets bigger and bigger. It starts to make sense. You got to keep going over it. So the first time around, it's like, what is this? And then the second time around, like, okay. And then, yeah, eventually it's like, okay, it's not a big deal. But you just
Yeah,
got to keep.
the more you see, the more it makes sense to you, especially
Yeah.
to me.
At first, it's really difficult because it's from I'm trying to go through the work and it's going by very fast, and I'm supposed to know, but I forgot a lot of it. The only stuff I got was a couple of it, and eventually I did get it. But yeah, I'm very much behind on this. I'm still trying to catch up. I'm still trying to write everything down.
I get you. So did you still need to write stuff, you said? Or
I wouldn't mind anything for I still need help.
did you, I mean, I'm saying, did you write down 6?
Um,
Very good.
number 6.
Yeah, did you finish writing the last one down? I thought you said you needed it.
I think so.
Okay. Back to the trinomial. Okay. I'm going to change this to x's because I don't like z or t or s. Okay. So what do you notice about this one before we start?
The X is what they have in common. I don't know.
Um, well, we're factoring trinomial, right? So do you notice that it's out of order? It's supposed to be the square first, right? So if you notice the question is not in order, rewrite it. Now you notice how there's not a number 1 in front of, there's a 5 in front of the x squared, so I should do AC method again, not trial and error. Okay. So my A and C are 5, -4, which is -20. All right. So find the factors of -20 that add up to 1. So -5, 4, 5, -4, 2, -10, -2, 10, -1, 20, 1, -20. So -5 plus 4, 5 minus 4, 2 minus 10, go all the way down. Well, we should be able to see the answer already, right?
Yes.
You don't have to go all the way down. I'm just being thorough here. It's the one we want. So break up the middle term to begin the AC method here. So plus 5x minus 4x minus 4. So I broke it down to these two. 5 minus 4 is 1x, right?
Yes.
So now begin the grouping. Is there any questions with this setup here and here? All right. Sorry, go ahead.
No, sir. There's no questions.
All right. What's the GCF of the first two terms?
5x,
5x. Second two,
-4.
-4. So now we get 5x factored out, leaving us with x plus 1. Minus 4 will be factored out of these two, changing them from negatives to positives. It'll become x plus 1, both positive. So now we got the same thing. So factor x plus 1, and we are done.
Yeah.
Any questions on number 7?
I'm gonna screenshot it real quick. All right, I'm good.
This one has a lot of steps, I noticed.
Yeah,
Very long. Yeah, we have
Oh
like
my
10
God.
minutes left. Yeah, I don't think we'll be able to get all of it done in time. There's like 20 questions.
Oh yeah, you're right. I don't know why I thought it was 540. Okay. Well, let's move on to binomials. So trinomials have trial and error or AC method. Sometimes those should get you through most of them. There might be a perfect square, but let's not worry about that now. There is no sum of squares. So whenever you see a square plus a square, we can't do anything. You see how we can rewrite that as 8 squared, right? Can't do a damn thing. So 14. Here we have a square minus a square. So we do have the difference of squares formula. Thirteen, 14. Yeah. All right. Actually, the trinomial or binomial. So this is the difference of squares. It's also on the sheet I sent you. If you have something squared minus something else squared, you're going to get a plus b times a minus b. Okay, so if from this example we have 49 minus 36d squared. So rewrite it as a square minus a square and then jump to here. So this will be 7 minus 6d squared. See what I mean? Now it's ready to do this.
It just simplifies it by having both as squares.
Yeah, we're factoring is what we're doing. We're just using a formula to do it for us. Okay.
I'm ready.
Any questions on number 14?
No, I'm gonna go ahead and write it down.
15?
Can you explain that second to last step on that one? So you're just adding the 7 and the 60 to both to get rid of
Right,
those
this
squares?
last from here to here?
Yeah.
Yeah, so notice once it's in this form, something squared and something else squared, and there's a difference. You just put the A's in here, A's and B's and A's and B's. So we have something squared, something squared. This is like basically like saying my A is 7 and my B is 6D. So they're here and here, here and
Okay.
there. But remember, we haven't been checking, but we should always be looking for a GCF. Do you see a GCF here? Or they both have in
Um,
common?
they're what they
3.
have in common is maybe. Let me see.
Just two, right?
Probably 3.
Excuse me. Yeah, just
3
two.
and 2.
Because 6 doesn't go into this one.
Yeah, it does not.
It looks like it should though, right? 16b squared. All right. So now rewrite them. This 2 is just going to hang out. That's 3a squared minus 4b squared. Put the brackets just so I can show you that this is something squared minus something else squared. Apply your formula. So we're going to get the a minus b, or a plus b. And then a minus b. And that's it. That's the another difference of squares. So as you can see, the goal for difference of squares is get it into some quantity squared minus something else squared. Once it's in there, apply the formula like this. That's all you're doing. Any questions on 14 and 15?
I just need to double check it real quick. So you split those two in the middle. Okay. 3a plus 4b. 3a minus 4b. That seems about it, sir. We only have like 3 minutes left.
Do one this one then. Sometimes you can have a difference of squares appear again after you're done. So first step, right? Always pull out the GCF. But here we go. Right. Next step, you have a minus. Can I write these as difference of squares? So let's attempt it. This is a squared squared, right? You agree that that is a 4 squared minus a 4 squared. Now we have what we wanted. Something squared minus something squared. So apply your formula and we get a squared plus 4 times a squared minus 4. But notice we have a second difference of squares, right? So rewrite this one as a squared minus 2 squared and do it again. So this happens every once in a while. You got to do it twice. So you get a plus 2, a minus 2. Right. I'm going to take roll. And that's pretty much it for this section.
Am I allowed to stay behind for work, for help?
Yeah, I'll help you out. It's no big deal. But can you take roll first?
All right.
And after that, y'all can head out once I hear your name. Is Abigail Garanza here?
Here.
Okay. Mia Acosta?
Here.
Leslie Espiricueta?
Here.
Katie Gaitan? No, Katie. Okay. Alejandra Garza?
Here.
Luz Gutierrez? No, Luz. Abigail Hernandez? Okay. Lucky Johnson?
Here.
Or Malachi, sorry. Danielle Lopez?
Here.
Abigail Carrion?
Here.
Jalen Mora?
Here.
Tiana Mora?